How to show my slides. Okay. Hello, everyone. I believe we are on live now. Hello, everyone. I am Ricky. I'm the CTO of NEST project, a PhD in financial engineering and applied mathematics. Today, we are going to talk about the OMM model and our PVM. And firstly, I will share our background, our history, how do we produce our products, and the evolution of the history of DeFi. Then we're going to talk about the OMM, a brand new form of the DeFi 3.0. And then last, we are going to talk about the PVMs, a virtual machine like the structure based on the basic function library. And then the chief engineering programmer of our team will talk about the PVM, how to access the system, and some basic codes they will show you. And we'll talk about how to DIY your own financial products. And now allow me to begin my talk. Well, most of you know the essence of any financial trading or financial product is just a swap of different returns with different risks. No matter the financial activity is an instant transfer lending, an option, or earning complicated derivatives. In the traditional financial market, financial intermediaries are responsible for maintaining the fairness of the trading. They are the deal makers who help the traders to find the matched the counterparties. In other situations, they are also responsible for pricing the financial products. The financial intermediaries includes diverse exchanges and deal makers of loan and asset auction markets. Together, they boost the efficiency of financial trading to the extreme. For instance, driven by high frequency trading, the exchanges allows the frequencies of their orders flow to arrive in nanoseconds. Although the traditional financial market has improved its efficiency, the credit risk within also increases. The inevitable hosting problems, as well as the power intervention of the financial intermediary, will raise the implicit cost of financial transactions. Those problems account for the main reason for developing DeFi. And here we can see an example. Let's say a trader, Alice. If Alice, a trader, wants to sell some assets or open a position in a centralized financial market, she needs to go to the financial intermediary, centralized exchange in this case. After filling in her required trading in an order table, the exchange will publish her order and find counterparties for Alice. And next, we're going to talk about the DeFi, the first generation of DeFi. As we all know, DeFi is the umbrella term for financial services on public blockchains. With DeFi, participants can do most things that banks support, earn interest, borrow, lend, buy insurances, trading derivatives, trade assets, and more. But it's safer, faster, and doesn't require paperwork or third parties. As which crypto generally DeFi is global, peer-to-peer, meaning directly between two people, not routed through a centralized system. Persuasive and open to all. The designer of the DeFi project in the early stage weren't aware of the particular constraint of the blockchain's technique. They launched their projects based on a simple idea. make financial tradings on blockchain and replace financial intermediaries with smart contracts to ensure no credit risk throughout the trading process. Following the traditional approach of the order book, the first generation DeFi writes every order into a smart contract, and the counterparty is open to the entire market. In the early designer's mind, openness is one of the advantages of their approach. The trading is not restrained in a local market. For example, when trading underlying assets, the traders only needs to decide the price and the volume they want to trade. They publish their order by a smart contract. When lending, the lender writes the amount, the time they willing to lend, and the interest rate they expect to gain into a smart contract. We call this generation of the DeFi 1.0. And the problem of DeFi 1.0 is the liquidity on the chain cannot be effectively assured. Fighting the final match, the counterparties still needs to centralize the institutions. Once a price once a price derivatives from the real value, the gas fee cost of the order adjustment is high. This traditional financial approach is not appropriate for on-chain applications. And we can also go back to our story of Alice. Alice now trying to trade with a DeFi 1.0 platform. She can participate a smart contract that specifies her request and waits for counterparties to notice her contracts. But this process normally goes very slow. Now, as the increasing number of people notice the liquidity and the cost of a pricing problem, the market approves the automatic market maker model proposed by Vitalik, the famous guy everybody knows. This model divides the two parties involved in trading into the liquidity providers and the common traders, and utilize a simple mathematical model. Most of you know is x multi y equal to k to calculate the impact of the trading on the price. This new approach reduces the cost of the order and saves the cost of finding matched orders. As a result, this model brings success to DeFi projects such as Compound. Even DeFi 1.0 Ethernet rise from the very bottom after adopting this model. With the AMM model, the traders no longer need to search for orders on the chain, and they can accomplish the trading by connecting to the funding pool. In the meantime, the seller and the buyers don't need to make their offer. They are both the price takers. The main advantage of this model is that the traders don't need to put or withdraw orders, while the disadvantage is putting the liquid providers into an unfair position. In principle, liquid providers adopt the determined trading strategies by depositing their paired tokens into funding pools, exposing them to the whole market. When an arbitrage opportunity appears, the arbitrageurs will be attracted to flock to the trading pair and cause impermanent losses to the provider. It is hard for liquid providers to earn excess earnings. For long-tail assets, this model basically becomes a tool for the project parties to subsidy the system or for junk projects to sell tokens. Similarly, AMM brings disadvantages to the lenders for the lower model since the price system can't lock the cost of the lending. Also, we can see the story of Alice again. Alice now can directly trade assets with the asset pool deposited by liquidity providers by participating in a smart contract now. Projects like MakerDAO utilize the DeFi market by allowing users to generate a kind of decentralized stablecoin. This kind of stablecoin is available to anyone, anywhere. Like DAI generated by MakerDAO is backed by a surplus of collateral that has been individually escrowed into audit and publicly viewable Ethereum smart contract. And we all know the DeFi 2.0 leads to a rising wave in crypto markets in 2020 since DeFi 2.0 projects provide a better solution to the fundamental problem of the DeFi industry, which is lack of liquidity. However, whether it is AMM or liquidity pools, the solutions to the liquidity problem is at the expense of the liquidity provider's flexibility. A liquidity provider needs to fix his trading strategy and bear the external market fluctuations. Since the price is favorable to the liquidity providers, the counterparty traders can opt to back out of the deal. Once an arbitrage opportunity appears, arbitrageurs can deal with them, then cause the impermanent losses for the liquidity providers. And the liquidity provider has no choice but to hope for subsides from mining and the commission fees or interest earned that can compensate their losses. Although this asymmetric design temporarily changes the liquidity shortage, it's generating the following problems in the long term. Firstly, many assets are occupied and deposited in DeFi protocols. At the same time, only a small volume of transactions is supported, which results in resource wasting. Most of the total value locked is still rushing into liquidity mining for profits. In the long term, the lower the capital utilization rate, the greater the loss of the intrinsic value of the DeFi products. Secondly, in the AMM, the core variables such as asset price and the interest rates are related to the size of the pool. When the size is small, it is easy to create arbitrage opportunities by high volume trading on one hand, and it is difficult to attract many traders and lenders when the pool is not large enough. On the other hand, moreover, a DeFi project's composability and liquidity sharing are not only at the technical level since the TVL of various DeFi platforms cannot be shared. This kind of liquidity created at the expense of a sacrifice providers flexibility is a big problem. And now it is better to erase this symmetric between liquidity providers and other traders, creating a brand new form of DeFi 3.0. This, which is the system can play the role of counterparties to all traders. This ideal complies with the decentralized spirit. Everyone in the same position to gamble with the smart contract. Whether the underlying asset is Bitcoin, Ethereum, or other crypto assets, the system burns the tokens immediately after earning participates pays the system tokens for some financial products, and minting system tokens will settle the income of the financial product. We call this model OMM, Omnipotent Market Maker. It frees us from the traditional financial trading models. It forms a new financial paradigm that not only ensure composability but also uniforms the programmability for all DeFi products within the same framework. Now we can go back to our story of Alice. Alice can now directly trade with the system by participating in a smart contract. The system will be her counterparty in this situation. In the scenario of DeFi 1.0, which is based on the order book model, and the DeFi 2.0, the AMM model, the smart contracts only play the roles of financial intermediaries. A trader has to find its counterparties, another trader or an asset pool. However, in OMM, the contracts become the counterparty of all traders. In OMM, one can settle all the payments by a uniform token. With OMM, one can also calculate the price of derivatives and any financial products based on expectations of future returns. For instance, given a European option that guarantees the holders the right to buy ETH at a certain time with a certain price in USDT, we computed the price of options by assuming the price of ETH to USDT follows a geometric Brownian motion with the relevant parameters calculated through the historical price information from NEST. When a participant enters a contract which uh, assures the participants to reserve a certain amount of tokens after a certain number of, number of blocks if the underlying asset price meets some certain condition within the blocks. The participants need to pay tokens to the system to purchase this contract, and the system will burn the tokens immediately after receiving them. If the condition is satisfied, the system will mint new tokens and pay the participants at a fixed block. As our opinion, OMM not only guarantees that any derivatives can be settled at any time, but also assures that any participants can open and close position or buy any financial products at any time, both of which can only be achieved with infinite liquidity. As, as we can see, all tokens holders share the risk and benefits of token insurance or destruction and participates in equilibrium of supply and demand in secondary markets for the tokens. The demand for tokens is from those who buy financial products on the chain and invest in tokens, while the token supply is determined by the initial offering and settled by smart contracts. The advantage of sharing the same settlement unit is that we can provide all financial services such as trading, lending, derivatives without issuing too many kinds of the tokens, but through continuously improving the liquidity of the tokens. OM model follows the core concept of asset pricing. When the price information is effective, any derivatives or other financial products can be priced, and the financial product is nothing but a linear combination of return functions of a financial product. If we find those functions, we can estimate the cost of the financial product by discount this function over time. This implies that we can purchase any derivative based on the Oracle machine's price information. Just like paying gas fees for programming a smart contract, this similarity ensures the openness of OMM, and we call this model DeFi 3.0. Now I see some of our audience have asked how many transactions per minute in NEST protocol. Well, basically, we can ask our programmer here. 飞哥你在吗？
在
飞哥，他们 B I 上有人问这个平均每1分钟在我们上面的那个交易数量大概是多少？还有交易成交额大概是多少？
这个每分钟那个有个几笔的样子吧，这个不一定啊，每天情况还不太一样啊。具体的数据的话，你要看运营那边那个来给数据。
嗯嗯。We're not very sure when Nest will on business. We're trying very hard to get on business actually. So what is probability virtual machine? Simply speaking, it is the probability virtual machine. It is a smart contract generators. It is an idea that to bring probability distributions to smart contracts. So the settlements of the contracts can have more stochastic outcomes. And why we need stochastic outcomes? One of the most important reasons is that the world is not deterministic, like the returns of the financial products, or more generally, an investment. To generate similar stochastic outcome is the key to manage risks. The next probability virtual machine, short for let's say PVM for short, is a virtual machine-like structure based on the basic function library. Developers can develop various exciting applications based on the function library, similar to Ethereum virtual machine. Nest inherits the gene of Ethereum. The essence of a EVM is that each program is a combination of some basic codes, which can be called as long as a certain gas fee is paid. The income of each product on the PVM can be regarded as a linear combination of some basic income functions, and this income can be obtained as long as a certain cost. That is, the discounted value of this income is paid. The underlying logic of PVM is the same as that of the EVM, which means that all EVM developments can be implemented on PVM. Nest is not just a simply copy of Ethereum. PVM can provide the calculation of random variables, which is a complete probability space relative to Ethereum. Any risk-return pair can be precisely expressed within the PVM. This means that the PVM have a large development space that Nest will be used as a gas fee payments method for PVM, and participants can obtain customized products that cannot be produced on other platforms after paying the gas fee. Further, all developers on Nest follows the unified standard of PVM, which provides great convenience for the interoperability and integration between projects, and greatly reduce the cost of forming the Nest ecosystem. Any financial trading or products, as we talked, is a swap of other returns with different risks. Whether the financial activity is an instant transfer lending or option and any complicated derivatives, the principle of Nest PVM is that according to a given discount algorithm, any financial products or derivatives can be decomposed into a stream of cash flow in and a stream of cash flow out. The cash flow in is the return of the financial product, and the cash flow out is the cost of the product. Moreover, the sum of the expectation of the discounted futures cash flow in stream is equal to or slightly smaller in the case of deflation than the sum of expectation of discounted current cash flow out streams. As we can see in these pictures, we might have several costs, let's say C1, C2, and C3, and some returns in the future. And these are the essence of financial product. And in PVM, financial products are considered as programming over the basic discount functions. The cost is the expense of calling those functions, just like EVM. The difference is that the economic relations of the discount computers are inherited. The new paradigm can cover almost all financial product services, which can be bought at any time and settled with unlimited liquidity, where market makers, margin call, and fear of being unable to settle are not required. As long as the next liquidity is sufficient, it would be easy to recreate the traditional financial markets. Moreover, as difficulties of insurance and settlements are solved, traditional derivatives exchanges can focus on secondary markets, thus significantly reducing their cost. In addition, PVM can bring the fundamental consistent variables for the metaverse with the ability to traverse different games to lock in economic relationships. Last but not least, the PVM includes two unique features. First, it guarantees infinite liquidities to the system, which allows any users can get any size of positions at any time. Secondly, PVM allows a complete probability space, which extends all risk-return combinations for the product development. With the NEST token, you can use to quote a price. And when you're quoting the price, you are providing the price information for other users. And you also can use NEST tokens to buy financial products or trading futures, buying options on our system. I guess this is the end of my part. Next, Jackson will talk about the codes, and we already have a demo for PVM. 飞哥，你来吧。
好的，可以开始了吧？大家好，我是 Jackson，是 NEST 团队的技术负责人啊。然后这个 PVM 的这个设计和实现，主要是我这里来做的。然后今天我就跟大家来分享一下这个PVM 的主要是它的实现啊。刚才那个 Ricky 把这个 PVM 的这个理论部分啊做了一些介绍，然后到了这个实现的话，这个 PVM 其实就怎么说，就是一个它核心的内容就是一个表达式啊，就是这个这里我们根据这个 PVM 的这个设计做了一个简单的 demo，可以看到它这个功能呢，是这个样子的上面就是有一个框可以来输入这个表达式这个表达式里面的话，目前呢是那个可以非常自由的 进行这个常量变量函数还有这个括号优先级以及这个函数嵌套调用这些功能实现这样的一个东西。然后呢，用法就是用户输入一个表达式然后呢，这个表达式可以是去估算出一个值，那么它在买入的时候，这个值它就是用户需要支付的这个成本，然后呢，这个就是它的那个这个 demo 的一个功能可以看到是非常简单的但是呢，它其实那个就包含了一个非常多的一个可能性，是吧？因为这个表达式那个用户是只要符合这个语法还有这个PM 的一些基本要求的话，是可以那个自由来组合定制的下面再来看一下这个表达式这个语法第一个有运算符有常量、变量优先级、括号、函数，还可以嵌套这个可以看到是跟我们那个一般的这个编程的时候那个表达式或者说是我们那个数学表达式它其实那个也大概是类似的包括这个符号也都是我们常见的这种符号。然后呢，它里面这个函数的话，它那个是我们知道它是有一个变量表还有这个函数还是可以嵌套的另外那个我们还要支持这个自定义的这个函数，可以通过这个合约来实现来进行一个注册。也就是说，假如这个系统内置里面没有你需要这个函数，那其实是可以那个按照这个 PWM 的这个函数的一个规范，你定义一个，然后来注册到这个 PWM 的这个有一个注册表里面去，那它就可以那个记入这个新的函数了这个是它的功能。然后呢，下面那个跟大家来介绍一下它的这个实现就是从代码这个角度来看核心就是一个表达式的计算它这个表达式计算的话，它是包括了刚才说的那些功能是吧那个变量、常量运算符、优先级、函数、嵌套这些东西。然后呢，这个表达式的那个计算，它的一个最基础的一部分，首先它是需要有一个解析的那么这个解析的时候，我们其实就用了有一个通用的一个方法，叫做有限状态机的一个方法这个有限状态机其实在那个边缘里面的话用的是比较多的，它其实就是对这种流式数据解析它是一种通用办法当然用在这个表达式解析上面的话也肯定是适用的可以看到左边的这张图就是我们定义的这个有限状态机里面的在解析的时候可能的一些状态初始状态就是解析那个整形解析那个标识符、括号、函数这一些，包括到了那个解析运算符以及进行计算这些状态都在左边这个有一个定义可以看到这个其实状态上也不多就这么一些。然后右边就是分别在不同的状态的时候，它应该是出于一个什么样的解析逻辑。但这个解析逻辑的话，它是每个状态它都有它独特的这个解析逻辑我把这个都给折叠掉了具体的我们就不去说它了。但是它大体思路就是这样子的我是不停的从这个表达式里面去取字符，根据当前的这个解析状态，我来决定这个字符代表什么意义这个就是一个有限状态机的这个方式来实现这个表达式的这个解析。当然解析完之后，这个还是有一个计算的那么这个计算的时候，它其实里面包括哪些第一个符号它是有优先级的第二个那个还有这个有括号运算是吧？它然后也是会改变优先级的。另外函数包括函数的嵌套这些的，而且函数的话，它有可能又是它的那个变量表每一个变量有可能又是一个表达式 这里面其实那个嵌套下来的话是一个可以说是一个非常复杂的一个东西但是呢，其实每一步都可以看到，它其实是那个它的这个处理方法是一个递归的方法那么这个其实我们在做这个优先级处理括号函数还有嵌套在处理这些东西的时候，其实呢那个它都是需要用一些递归的方法来处理当然呢那个实际上这些递归理论上都是可以把它用展开成循环来做到的但是呢我们在这个合约里面的话，其实那个用这种递归的方法其实你只要把这个入口处理好了就是在实际上这个代码还会显得更加简洁逻辑上也会更加清晰可以看到这个这两段代码左边和右边，左边这个呢就是有一个括号表达式它里面那个就是怎么说呢？对于括号里面这个部分再会有一个递归的有一个调用可以看到有一个计算表达式，这个其实它那个这段代码它就是在这个函数里面定义的，包括右边这个也是这个是一个计算函数它的这个变量表的时候可以看到它每个变量表它其实又是一个表达式，当然可能我们通常的话它只是一个标识符变量或者是一个常数是吧？但是呢事实上它也可以是一个表达式的，包括这个表达式有可能它又是一个函数可以看到它其实这里面就有一个递归的调用当然那个除了这个之外，那个优先级也是会有一个递归的调用的这个在右边这张图里面它也是有一个处理优先级的这一部分，然后左边这部分的话，这个就是我们这个主要的这个函数刚才可以看到它其实那个内部是不停的在递归调用自己的在说到这个递归的时候其实我们这个程序员那个或多或少应该都是接触到了是吧总觉得这个递归还是很有用的，但是呢用它的时候又总感觉那个好像太灵活，很难的去把握。那么其实我们让这个程序员在做这种递归的时候怎么样子能够让他能够得心应手，然后那个把它这个用的非常那个应用自如呢其实我总结之后你这个递归其实就是要把这个边界弄清楚。什么叫做边界弄清楚？就是我的每一个函数，我的定义是什么，输入是什么，输出是什么，我要非常清楚这是第一步。第二步就是当你递归的调用的时候，你要让这个输入和输出要能够衔接这个那个打个比方，就像什么，就像我们在设计那个地板砖这个样子。你地板砖你不是设计任何图案都是可以的，你设计的任何图案的话，你是吧？图案的那个地板砖你拼在一起，你会发现它那些图案是拼接不到一起去的但是呢，有一些图形是可以拼接到一起去的，这个是什么当然它有它的一些方法但是重点就是它要能够图案之间能够衔接那这样子的话把这个边界处理好然后那个输入输出能够衔接上，那么这个这个递归其实用起来的话就会感觉到非常清晰那个也不会觉得它有多么困难当然这个递归其实是一个非常好的工具下一个再还有一个就是刚才通过这个表达式的解析和一些递归的处理之后，就可以把这个表达式能够解析出来了，而且它的这个每一个部分是吧？这个优先级也能处理，括号也能处理这个嵌套都能处理了。那接下来的话就是标识符，这个标识符的话，它其实也是需要处理的。我们第一类标识符就是那个定义的一些内置变量比如说我可以把那个派是吧定义成一个内置变量自然那个底数那个 e， 然后也可以把它定成一个内置那个常量另外呢那个映射表的形式，就怎么说？当你那个找到这个标识符是吧？那么对应的它除了解析到它那个参数表之后，那很重要一部分就是要找到这个执行这个函数它对应的具体那个代码。但这个具体代码的话是那个后边这个人来注册上去的，那么就要注册这个 注册表里面去。所以说这里面就定义了，然后有一个注册表。但这个注册表的话，那个为了简化，把它这个 key 就是那个就是映射表的那个标识符啊，把它那个转成了一个整形来处理啊。这个左边上就是它那个的一些那个转化啊。当然最重要的一个就是在下面这个 reset static core 这个方法就是用来注册就是自定义函数的。那么右边这个的话，它就是那个执行这个这些自定义函数的还有变量的啊。当然这个右边这个是这个变量和那个接口的还有一个那个自定义函数。自定义函数的话，它里面会更加复杂一点啊，就是在下面这一张 PPT 里面啊。这里面的话就是让那个在处理这个自定义的这个函数。自定义函数，然后刚才说到我通过这个解析得到这个标识符是吧？这个函数的这个标识符，然后通过刚才的那个映射表里面的话，我就能够找到这个函数的实现代码了然后接下来的话就是要组装这个参数表，然后来进行这个调用。那怎么组装呢？这个然后又和这个以太坊这个虚拟机它有这个关系。它这个以太坊虚拟机它那个调用的时候，它这个参数是怎么编码的？我们就要按照它这个方法来进行一个编码当然呢，它那个以太坊它那个本身它提供了一些内置的函数有那个 API encoder 那些系列的那个函数可以用来进行这个参数的这个编码。但是呢，我们这边有一个问题，就是我们这个变量它的个数是动态的，也就是说那个你是不知道这个标识符它对应的这个变量它是你在写这个就是这个PUM 的这个实现的时候，你是不知道每个函数它是什么样子的，也就是它这个参数表是动态的。那怎么办呢？那这个时候以太坊虚拟机它提供的那些函数，它都是固定参数的，那它就不能够直接用上，那么就要自己来进行这个编码所以说那个就有了这两段代码。这里面的话主要就是按照它那个 API 编码的格式来生成这个就是调用的这个数据的编码首先左边这部分先是要组装它那个签名部分就是那个函数的签名包括那个函数名字括号以及然后每一个参数的那个类型拼起来这个是那个以太坊 UVM 调用的时候那个规范。再接下来的话就是参数的话每一个都要按照它那个方式来组装成这个这个字节拼成一个字节放到里面去。当然这个里面做了很多的优化包括后面这个用这个嵌入式汇编这个后面两段用这个嵌入式汇编，然后把那个参数能够更高效的把它拼接在一起。拼接完之后，然后它后面的话它就是它就让那个可以给那个注册的那个接口去发这个调研消息就可以来执行了核心的部分就是这些刚才只是简单讲一下，实际上这个实验的话，它那个里面做这个东西，它其实还是有一些复杂的就是具体的这个代码的话后面给出来了这个大家有兴趣的话可以上来看一看包括有什么问题也可以交流一下好了接下来是怎么办呢？
接下来就算是这次直播差不多就到这里了，飞哥。
我们就直接就结束退出吗？还是怎么搞？
就是还是要跟大家讲一下。
有什么联系方式可以留一下的吗？
联系方式电报。
对，然后大家有什么问题的话，就可以通过电报联系一下，都在直播间视频下方的详情里面有。好，那我们今天这场直播就到这里了。
Thank you very much, guys. Thank you to stay with us. I'm sure this series and those codings are extremely boring, I understand. But you still stay with us. I'm sure you are one of the smartest traders. Thank you so much to stay with us. And we're expecting to see you again.